Hello everyone, I am Tejas Kumar and this is proof video for Liquid Galaxy Google Summer of God 2023. These are the three rigs. This is LG1, this is LG3 and this is LG2. LG1 is the master machine, LG2 and LG3 are slave machines. As I zoom it in, you can see as I move the master machine, all the three other machines are also moving. That means that all the three rigs are in sync. So moving forward, the other thing was to test the applications, and for that I will have to open Bluestacks. As the Bluestack is open, I will first try Liquid Galaxy controller. The app is connected to the rig, so if I click on moon, it will move to moon. Sorry, slip of tongue. And here is moon. Same way we can zoom it, and we can even go to different places on moon. As you can see, these are some different locations. Like in earth, you can see there are different locations. They can be tried. I have tried them early, but to keep the video short, I will not try them here. I will switch back to earth. So earth is here. Okay, and we are back at earth. The second app is the La Palma app. And here in custom builder, yeah, I can select different what I want to see. For example, I want to see the main eruption wind or the lava flow. I have selected it, and to visualize it I can go to visualize in LG, and our globe will rotate and go to La Palma. As you can see, in green color, it is the main eruptive event, and it is lava flow in the purple color. So this was my pre-selection video. Thank you all.
Everyone, I am Aditya Kumar. This is my second video for pre-selection process. Here I have made one app using Kotlin, in which I have used Liquid Galaxy logo consisting of 4 buttons: button 1, button 2, button 3 and button 4. I have used Android Studio as ID. Thank you. Hello everyone, I am Aditya Kumar, a second year BTech student in India. I want to show you how I have installed Google Earth in my virtual machines. Here I have Oracle Virtual Machine VirtualBox Manager, in which I have made 3 Mark 1, Mark 2, Mark 3. Mark 1 is master machine, Mark 2 and Mark 3 are slave machine. Let me launch all of them. Here the Google Earth is working properly, so let me zoom in. So the Earth is rotating very well. So once, let me zoom out also. I have downloaded it using the Liquid Galaxy installation document that was posted in the official website, so it helped me a lot during the procedure. So thank you everyone.
Okay, so hello everyone. My name is Amanjot Singh, and today I'll be presenting my three VMs running LG project, and the fourth and the last VM is Liquid Galaxy Controller app. So let's begin. These are my three VMs. This one is the master machine, and these two are the slave machines. Okay, so this is the LG1 machine, and it is the main part of the Liquid Galaxy project. And if I zoom in, all the other VMs are able to sync with the master machine. Okay, so if I go like this, they are able to sync perfectly. Okay, so now let's become yeah. So let's search about the CN tower. It's searching and see, it works. It's a bit laggy. Uh, Maybe it's my network or something. Uh, I can figure it out, and it's working perfectly. So as this prelim step is complete, I'll be working on the app in which I have to present the Liquid Galaxy logo and the four buttons. I'll try to make it uh, today, by today or by tomorrow itself, and will be leaving a message on the Discord that I have completed the tasks. Thank you so much.
Hello everyone, my name is Arnav Sarkar and this is my proof of knowledge video for Liquid Galaxy's Google Summer of Code program for 2023. So the task we were given was that we were supposed to set up the Liquid Galaxy rig on our local machines. The rig consists of 3 virtual machines running simultaneously. So as you can see, I have the 3 VMs set up here. In the center I have the master virtual machine and on either side I have the slave VMs running. So if I move the globe on the master VM, you can see it works in sync with the slave VMs as well. So all the 3 VMs are in sync with each other and they're displaying the same globe. We were also supposed to have an Android emulator running to control the whole rig. So I have the Android emulator set up here, as you can see, and I have installed the Liquid Galaxy Education Controller app on it. So if I press on play here, and this is a sort of a quiz on the app as in the cities of Europe. If I press on play here, you can see the question here it's asking is which is this city. So we have the Eiffel Tower here, so obviously this will be Paris. So as you can see, the 3 VMs and the Android emulator are working in perfect sync with each other. So that was the first task we were supposed to do for as a pre-selection requirement. And in the next task we are supposed to make a simple Android app consisting of the Liquid Galaxy logo and 4 buttons, which I'm working on right now. So that's it for this proof of knowledge video. I hope to be working with Liquid Galaxy in this year's Google Summer of Code program. Thanks for watching.
Hello everyone, my name is Arvind Sinha. I'm in my second year pursuing computer science and engineering and I'm from IIT BHU. So today I'll be demonstrating you the Liquid Galaxy Task 1 on the website. So the task required me to configure 3 virtual machines working simultaneously. So I have the respective machines here, LG1, LG2 and LG3. With LG1 being the main machine and LG2 and LG3 being the slave machines. Now let's see. We can see that these machines are working quite nicely. Let me first stop the earth first. Yes. Navigation, and I'll disable the enable controller machine, and as we can see the earth has stopped. So the second part of the task required me to download an LG app from BlueStack and show specific regions on the basis of the conditions. So I have downloaded the BlueStacks app, and as we can see we have an app called La Palma Volt Track. So let me open it. By the way, I've connected the this app with the main machine through the IP address. So for example, if I want to get the prehistoric map in on my machine, I can just do this, and we can see that. We can see that we have the prehistoric map on working on our 3 simultaneous machines. Basically, this was a task that was given to me. Thank you so much.
So, hello everyone. My name is Himanshu Barde and I am pursuing mechanical engineering. I am a sophomore from IIT BHU. So the first task assigned to me was to set up a Liquid Galaxy rig on my system. So here, as you can see, the three rigs have been set up and are working quite nicely and synchronously. You can see I am also zooming in here. Now the second task assigned to me was to open an app on BlueStacks and see how Liquid Galaxy is working. So here we open La Palma Vault Track on BlueStacks, which is our Android emulator. We can choose any of the options, so I am selecting here prehistoric map and we click on visualize in LG. So here it opens. You can see it's working quite nicely and we can see everything on the rigs here. Thank you very much.
Hi, I am Likith from India, currently pursuing BTech in Computer Science, and I have successfully completed the first task of in setting up the virtual machines. So the one in the center is the master machine, and the nodes in left and right are the slave nodes, and we can clearly see both the master and slaves are completely in sync. And the fourth virtual machine is an Android emulator wherein I have installed Liquid Galaxy controller app. The IP address of master machine is registered in the app, and we can control the master machine using the Liquid Galaxy controller app. And we can see both the masters and slave are completely in sync. Yeah, that's it, and I am eagerly waiting for your response.
Hello, my name is Manas Kumar and I am from IIT BHU pursuing electrical engineering and I am in my second year. So I am here to present a video demonstration of the task one that was on Liquid Galaxy website. The description of the task was that we have to create 3 virtual machines and install a Liquid Galaxy rig on all of them and then sync them with each other. So for that I have here installed Oracle VirtualBox Manager. Here I have created 3 machines, namely LG1, LG2 and LG3. The LG1 is the master machine and other 2 subsequent machines are slave machines. So I am going to start them. The 3 virtual machine has started and the Google Earth has auto launched itself. Now we can see the Earth is auto rotating. So to turn off we have to go to tools, then options, then to navigation and disable this enable controller. Now it has stopped auto rotating. We can see that all the 3 machines are in sync and I can control them using my master machine only. Now the other part of the task was to create 4th virtual machine or download any Android emulator and download 2 Liquid Galaxy app from the Play Store and run them on this Liquid Galaxy rig. So for that I have downloaded Bluestacks. Here I have downloaded 2 Liquid Galaxy apps, namely La Palma Vault Track and LG Edu controller. So first we will try La Palma Vault Track. Here there are many options which we can visualize on LG rig. I will select lava flow map and then click on visualize in LG. And as you can see, the LG has rotated and is going to the location of this lava flow, and we can clearly see the lava flow map on Liquid Galaxy using this app. Now again we will go to another app, that is LG Edu controller. And here there are many options to go on the LG rig. We will select CN tower and the LG has now again rotated and is going to the location of CN tower, and we can clearly see that on LG rig, and we can also control and navigate through this environment in LG rig that I had to do and which has been successfully implemented. And I have used a Liquid Galaxy installation manual to install all the rigs. and then have used BlueStacks to and then have used BlueStack to run Android, and then downloaded the apps and configured them using port control and port forwarding method. So this was the task. This is how I had completed the task. Thank you.
So hi everyone, my name is Pratyaksh and currently I'm in my third year. I'm pursuing BTech Computer Science and Engineering and I'm from India. So from here you can see that I've created 3 virtual machines, and Mark 1 is the master machine and Mark 2 and Mark 3 are the slave machines. And I'm able to control this using my master machine, and these are the 3 virtual machines that I've created. So I think I'm done with the first task and waiting for the feedback. Thank you. So hi everyone, my name is Pratyaksh and currently I'm in my third year. I'm pursuing BTech Computer Science and Engineering and I'm from India. So as far as Liquid Galaxy is concerned, I've taken 3 virtual machines. Mark 1 is my master machine and Mark 2 and Mark 3 are my slave machines. Basically at the center is my master machine, and I've opened Google Earth on all the 3 machines. So now as you can see that I'm able to control Google Earth from my master machine, and it syncs on all the same machines too. And for the fourth Android emulator, I've used BlueStacks as an Android emulator, and have opened Liquid Galaxy controller so as to check whether my app works with all the 3 virtual machines or not. So now let's say we change our celestial body. So as you can see, our celestial body has changed, and we can also control it from a master machine too. So let's get back to Earth. Now let's check whether we are able to search something or not. Let's say we search for London. So now let me click on the search button. So as you can see, I'm able to search from my Liquid Galaxy controller, and it syncs on my 3 virtual machines, and I'm able to search my landmark. So now let's search something else. Let's say we search for MIT, and we click on search now. So now we can see that the Google Earth syncs on itself on the 3 virtual machines, and it makes us get through the MIT. So I think I'm able to manage through the task 1, waiting for the feedback. Thank you.
Hi, my name is Prayag Biswas and I am a third year undergraduate student from IIIT Kalyani, India. Have you ever wondered how it feels like to view Google Earth in a panoramic view? That's what Liquid Galaxy does. Liquid Galaxy is a very cool open source project founded by Google. It gives a cluster of computers the ability to fly around Google Earth, view panoramic videos and photos, develop interactive tours, and graphically display GIS data. When it was created in 2008 by a Google employee, Jason Holt, it was only a multi-display panoramic viewer of Google Earth. Since then, through the Vision port and contributors all around the world, it has reached to a whole new level. Now it is used by museums, universities, corporate office and commercial enterprises all around the world by connecting large panel of HD TVs in a panoramic environment. So let's see how it works. So this is the snake game from LG Retro Gaming. I press ready, started the game. So as you can see, all the 3 VMs have been merged to provide a single seamless display of the board. I cannot catch a single food. So yeah. So let's kill the snake and go back to our Google Earth. So this is the Google Earth and LG one is the master and left and right one are the slaves. So if I type Kolkata here, it should take us to Kolkata. So here we go. And you can see it is taking us to the Kolkata. So yeah, that's it. Thank you.
Hi, my name is Ryan Kim. I'm a current third year student majoring in computer science at the University of British Columbia in Canada, and I've been interning at SAP as a software developer intern since last semester in Vancouver, and I hope to continue my journey at Liquid Galaxy through the Google Summer of Code. And if we just hover over, we have our 3 virtual machines. So currently we are on the moon, and we can zoom in, zoom out, and then if we switch to Earth, okay, there we go. And now we can navigate through Earth as well. And if we also switch apps from the controller to the volcano tracker, we can try, let's say, going to info and let's pick let's go with located events map. And if we click this button, then we will start the orbit and it will show on the virtual machine. And yeah, that's my little bit, short introduction, and part 2 demonstrating the Flutter application will be coming soon. Yeah, that's all for today. Thank you.
Hi, my name is Sahib Pradhan, pursuing data science and artificial intelligence from IIIT Raipur. So my first task with Liquid Galaxy is to set up the virtual machine. So as you can see, there are 3 virtual machine, and on the middle it is a master virtual machine, and on left and right they are the slave virtual machine. So if I try to control the master virtual machine, automatically left and right slave virtual machine get in sync with the master machine. So my second task is with this simulator, I can change the appearance of like here it is moon, so I can change it with Mars. So the change is visible here. If I try to zoom, the changes is visible on all the 3 virtual machine. So yeah, that's all. And I will be submitting the Flutter app as soon as possible. So thank you.
Hello everyone. Today I'm going to showcase my Liquid Galaxy setup of 3 VMs and my Android VM apps running on it and interacting with it. So the first app that I'm going to showcase is Liquid Galaxy Retro Gaming, connected to my 3 VMs LG1, LG2 and LG3, where LG1 is the master and LG2 is my first slave and LG3 is my second slave VM. So let me just start it off right now. And we're in the game. So I'm using the Android VM to interact with the game on my LG VMs. And I got 1 pellet and 2. And now I'll just switch over to my second app that I wanted to showcase, the LG controller. So for that, I'll just exit out from my snake game. Just a sec. The snake is dead. And here we have Liquid Galaxy, Google Earth. And as you can see, I was roaming about the Eiffel Tower right now. So let me just zoom out and show that it's all synced and interacting well. And let's try traveling somewhere else now. So maybe let's do Tokyo Tower. Search. And here we go. Around the globe. And here we have Tokyo Tower. So here we had my Liquid Galaxy setup. I hope you enjoyed. Thank you for watching and goodbye.
So this is my recording for Liquid Galaxy installation procedure. get it down on how I can install the whole thing. So here are the steps which I follow to install Liquid Galaxy on my Windows computer, and I recommend that your device should have a minimum RAM capacity of 8 gigabytes, because anything less than that would most probably have a hard time running. So these are the two prerequisites which your computer should have. One is the Oracle VM VirtualBox version 6.1.4. Yeah, you should remember about the version being, if you install the latest version, which I had done originally, then you would encounter a lot of problems in the network, in building the NAT network, since the IPv6 would not be supported, and I don't know how to deal with that. So I recommend that you install the 6.1.4. I've provided the link here. You just go and press on Windows hosts, and that should give you the required version. Then you should also download the Ubuntu image file, and the link for that is also provided. It's like 1.6 gigabytes, and this is mandatory, since you would have to install the OS on your virtual machine. This guide is mostly towards Windows, and if you want to check out for Mac OS, then I would highly recommend video from Yashraj, who has done a great job at explaining how you can install it for Mac OS. Even though it is for Mac OS, most of the steps I followed are also taken from there, since it's pretty much universal. So let's get started. First, you need to install Oracle VM VirtualBox. Once you have installed it, then you should open the application. And right now, all three of my virtual machines are running, but I'll show you the steps I followed to create each of these virtual machines. So first I press new, then finally let's name it LG4. Type should be Linux, and Ubuntu 64. Yeah. So one thing you should note: this interface is totally different in the latest version of Oracle VirtualBox, since that is why I had a hard time creating the same setup in the latest version of VirtualBox. So I recommend 6.4.1 and then following the steps. So once you're done with that, the RAM should be around 1800 to 2 gigabytes. Then press create VDI, dynamically allocated, and the size should be 18 gigabytes as recommended by Liquid Galaxy. The VirtualBox would be created something like this. Repeat this step 3 times, and you should get LG1, LG2, and LG3. Then go to settings. First, to see the settings part, I would again recommend the original video from Andrea Ibanez on how to install Liquid Galaxy on VM's VirtualBox. A really helpful video, totally explains everything in details. I use this to get the first initial part of installing the whole process, and the remaining from this video, and both of them together work perfectly. So then you would go back here, and we would first go to display, set the display video memory to 128, or the maximum as it can go for your device. Then go to storage, controller ID empty, click on that. Then optical drive, here you should choose the disk file, or go to the video folder where you have installed the image file, and then open from here. You should load this up, or you can directly go from here. Then you should go to network, and here in network you should always give NAT network. This is a must, and nothing else is needed to be done from here. Once this is done, save the settings. Make sure to check out the network property, because here, if you don't have a NAT network, then very problematic. Yeah, to get the network you should first go to File, then Preferences. There you will get the network part. Here in network you would get the original network, and then you should click on Properties. Here you should support IPv6 and then OK and OK. Do this for all three of them. Settings. All three of them should have the network. That is a must. Once that is done, run all three of them. Yeah, all three of the virtual machines should be running. And should I run this? Yeah, let's run it. In case this becomes too long, you can really check out these two videos. The initial process of installation, which I'm showing now, can be completed by this video, and once you're done with that, check out this video, and everything else on what you should do is listed here, and you can always refer to the guide on what you should do, what steps you should take, and especially step 4 and step 6 are really important, so you should keep in mind on completing them properly. And after that, yeah, everything else is pretty self-explanatory. So I hope it helped, and this is how you would be able to pretty much, yeah, you should install and then same things. After that, you should be able to get yourself this setup pretty easily, and I hope that helped. Thank you.
Hello, my name is Ritzel. I am currently in third year pursuing computer engineering in India. So today I am going to demonstrate Liquid Galaxy in 3 virtual machines which I have already installed and set up. So I'll follow the documentation of Liquid Galaxy. So I will quickly explain what I have set up. LG1 is the master machine, and LG2 and LG3 are the slave machine. As you can see, after setting the Liquid Galaxy project, you can see Google Earth. So you can see that all 3 machines are perfectly synchronizing. And second task was to download the LG app. I have choose the LG controller, and as you can see, I am running in the Bluestacks. So after the 3 selected already, I am selecting the mass one. Yeah, you can see like all 3 machines are showing the mass 3D image. So like all 3 machines are perfectly synchronizing for the mass as well. Yeah, I can zoom in and zoom out. Yeah. So the second task was to create a Flutter app with 4 buttons in it. So I will soonly upload that file in the email.
Hello, my name is Vinicius. I'm 24 years old. I live in Brazil. I currently have a degree in computer engineering for Facens University in Sorocaba, São Paulo, at Brazil. And since 2021, I've been collaborating to the Liquid Galaxy organization in Brazil. Today I will show my Liquid Galaxy installation. To set up all the things, I followed the guide into the Liquid Galaxy page. So here we can see at 3 machines Liquid Galaxy, and then we can interact with the Google Earth application. That's the default one. So we can zoom in, zoom out, rotate, pinch, and so on. Also, past GSOC students made some apps to interact with the system, and I will show 2 of them. The first one will be the RAS application that was started by Karine on GSOC 2021 and was continued by Siet on GSOC 2022. So all the applications connect with the Liquid Galaxy using the SSH protocol. So on the settings we can set the IP address, and the password of the machine. And then we can do some tasks with the Liquid Galaxy. The RAS application allows us to plan reforestation areas. So here let's see the Atlantic Forest. When we launch on the Liquid Galaxy, we can see the area, and then we can interact with them. The other app that I will show is the Beam Liquid Galaxy Visualizer. So the idea are the same. We type the IP address and the password on the settings, and then we can do some tasks with the Liquid Galaxy. So here we can reboot, shut down, relaunch, open, clean logos. So let's try the shutdown. When we execute, it shuts down the machine. So for now, that's it. Thank you for your attention, and bye.
Hello everyone, this is Aditya Sankla, a computer science undergraduate student from IIT Bhilai. This is my Liquid Galaxy setup. As you can see, I have set up 3 virtual machines. The center one is the master virtual machine, whereas the left and the right ones are the slave machines. I can zoom in, zoom out, and drag to view the surface of the Earth, and it is synchronized on all the 3 machines. That was my submission for the first part of the first task. For the second part, we had to connect a Liquid Galaxy application to the master machine. So to implement this, I'm using Bluestacks Android emulator. And now if I click on the moon, it is being synchronized on all the 3 virtual machines when I zoom in. Now I can view the surface of the moon, and so I have connected a Liquid Galaxy controller application to my Liquid Galaxy setup. That was my submission for the first task, and I'm currently working on the second task, which is to build a basic app for Liquid Galaxy. Thank you.
Hello everyone, my name is Ana Laura. I'm a second year student of Systems Analysis and Development here in Facens University in Sorocaba, Brazil. Well, I've been working as an intern for almost a year now in Liquid Galaxy Lab. And I hope I can participate in Google Summer of Code this year. These are my machines. Here we have LG2, LG1, and right here, LG3. So I'm running Liquid Galaxy controller now. We can see the moon. I'm gonna switch now to Earth. It's all running, alright. Can go to somewhere. So we can see all this view. And now I'm gonna run La Palma Volcano Tracker so we can see lava flow map. And it's all running alright too. Oops.
Hello, I'm Ankit Kokne, and this is the video for 3.3 task for pre-selection of Liquid Galaxy for GSOC. So the idea behind making this app work was to try the app with various different versions of Flutter. So I started off with 1.2.1 and then worked my way up to more recent versions of Flutter SDK, and then I found out that 1.22.0 was a good base to start off. Then I started working on the plugins and found out that some of these plugins did not support Android X, like the barcode scan, plugin did not support Android X, and there was a block plugin that also didn't support Android X. So I upgraded them or changed them to a plugin that did support Android X. So first of all, in Gradle properties, I enabled support for Android X, and then I also enabled Jetifier, which solves compatibility issues for plugins with Android X support. So next, I was facing some issues with Groovy, which I found the solution for by using Gradle 5.0, which is also compatible with the version of Kotlin our app was using. Then I changed the target SDK version here to 32, which is one of the latest Android SDK versions. And I also disabled R8, which is used for shrinking the application, as it was causing some issues while building. Then I upgraded some of the plugins here to support Android X, and then I had to make some changes in the code so that they could accommodate the new plugin versions. Then I followed this build and release. Then I followed this guide to build and release an Android application, and I added a key.properties file, and I made some changes to the build.gradle file. So this file contains some information that is needed to sign the application using the JKS file. I would also like to mention Prayag, who helped me solve some of these issues I was facing when making this app work. So with the OSC backend server, even though a newer version of pip is installed, for some reason it is using pip 8.1.1. So I've also tried to install various versions of Python from source, but it just doesn't work. And newer versions of Python aren't supported on Ubuntu 16.04 because the dependencies are just not present.
Hi Liquid Galaxy family, this is Ashutosh Gulge, a second year undergrad at VGTI Mumbai. This is a prerequisite video for task 3.2 given to us all. Uh, so this is my Liquid Galaxy having containing 3 VMs, and fourth VM is a virtual device, that is I am using Bluestacks. See, you can see it is perfectly working. Then I will try to search something, country, here, India. Uh, Now search, see. To redirecting to India. It's done. Then we search a stadium. Narendra Modi Stadium. I will search Narendra Modi Stadium and Baba there. See, it's redirecting there. Working smoothly without lags. Uh, Now I will change the planet. Uh, Planet to Mars. Takes a little pause. Say Mars. Perfectly running in all 3 wings. Not unnecessary rotating. Then change it to Moon. And zooming here. And rotating. This point is also showing here. Luna. Same is going in third wing. Now back to Earth. Now we'll try one app. Mhm. I will try the app by our mentor, Yashraj. It is La Palma. See, I have connected La Palma app also to the VM. Connected. Now let's select our prehistoric map here. So now it is ready to visualize. When I click on map, it will redirect in map. It will take some time. Yes, it is working now. See, perfectly uh, smoothly in all 3 VMs. Yeah, Parma here, here. So info. I have shown all the requirements of Video 3.1. So thank you.
Hello everyone, this is Atharva Kuntakar and I am currently in my second year of computer engineering and I am from India. This is my Liquid Galaxy setup which consists of 3 VMs. It currently has the Google Earth loaded on it, and if I this is my master VM and these both are my slave VMs. So if I just zoom into it, it's fully functional and I can control it. So now I'll be showing the working of the app. So this is the app. I've also changed the app icon from the actual Flutter logo to the Liquid Galaxy logo. So if I open it, it gives me the splash screen which pops out for around 4 seconds with Liquid Galaxy as the text. So this is our home screen and it consists of the Liquid Galaxy logo. Then there is the text which I had shown in the video in the earlier video, and the text font is unbounded, which is a Google font. And these are the 4 buttons which consist of URL, and all these are clickable. So if I click on our website button, it takes me to the website page of Liquid Galaxy. So if I click on GitHub, it takes me to Liquid Galaxy GitHub, and also there are icons which you can notice over here. And if I click on Discord, it gives me the Discord server, and if I click on installation, so it gives me the LG rig installation video on YouTube. Thank you. Hi, this is Atharva Kumtakar and this is my Flutter app for the Liquid Galaxy project. So this I have used VS Code as my IDE, and this is the main.dart page. It consists of the run app method which will run the app, and also it consists of the home method which tells me where to go next. So I have to go next to the splash screen. So this is the splash screen page. So it tells us that the page will be running for around 4 seconds, after which we will be directed to the real home screen of the app, and it is inside a stateful widget because we have to perform any functions over here. This is the decoration of the screen, and I have included the colors of red and blue in a linear gradient form in the main gradient method, and I've also added a text of Liquid Galaxy with a clipping of an image. So we have to go to the home screen next, as there is a material page route which directs us to the home screen. So the home screen has the 4 buttons and also has the Liquid Galaxy logo which you can see over here. It also has a text widget which I'll be showing you in the app, and then there are the 4 buttons which each of these buttons, they consist of a URL which directs us to a web page. I'll also show you my pubspec.yml file which consists of all the images that have taken in the assets folder, and also of the font which I have downloaded from Google Fonts, which is unbounded.
Hi, my name is Bhumik Shetty and this is my video submission for Liquid Galaxy for GSOC 2023. So, as we were told to start 3 VMs with the Liquid Galaxy rig and Android emulator to control it. So, here it is, and we were told to choose 2 of the applications which is on the Play Store. So one of that is the Liquid Galaxy retro gaming applications, out of which I have selected Galaxy Snake a game. So we click on ready. So yeah, it's starting in 3 2 1, and here we can play the game. Yeah, it's a little difficult to control it like this. Okay, so we can pause it, we can restart it, we can again press on ready and it will get started. So this is one of the application, and the other application is La Palma volcano tracker. First of all, let me just kill the snake game. So yes, it's done. Now let's look at our La Palma volcano tracker. So let's visualize historic track map. It's ready to visualize. Now we hit visualize on LG, and we can see that it navigates us to the place. All right, we can look at some other data too, such as SO2 emission map. Let's visualize that. So yeah, we can see it. It's loading. Let me just, yeah. So we can see the SO2 emission map all over the world. Situation map, visualize. So yeah, this is my submission for the prerequisite tasks. So I'm very excited for further steps. Thank you.
Hi there, my name is Dakshin Rajesh and I'm in my third year, currently pursuing my undergraduate in the field of biotechnology from the prestigious IIT BHU, Varanasi, India. I have previously interned as an Android app developer with the Ministry of Defense, Government of India. I have completed my first task allotted to me, and this video is a proof of setup of the virtual machines required for the Liquid Galaxy project associated with Google Summer of Code 2023. So here we are. We have all our virtual machines running up, and all these machines are also synced up with the master machine, where the slaves are being synced up with this. And we can make sure of this by zooming in and out. So if we try to zoom in, yeah, you are able to see that the side view generated by the master machine is taken in by the slaves and is in well sync with each other. And hence we can say that Google Earth and Liquid Galaxy has been completely and successfully set up in our case. So now we move with another emulator, which is also a virtual machine, where we are going to control two applications, Liquid Galaxy Controller and La Palma Voltrack. So let's begin with Liquid Galaxy Controller. So now this is an application where we will be able to select various monuments and cities and view them in Liquid Galaxy. So let's choose Grand Canyon. Then Liquid Galaxy takes us to that place and the view gets rendered over here. So this is a proof that Liquid Galaxy controller has been successfully integrated with our Liquid Galaxy. And let's move on with another application, which is La Palma Track. So here we have 8 different options, and let's choose one of those. Let's choose SOT emissions map. Clicking on this sets the topographic value, and we are now ready to visualize it. And if we click this, the data gets visualized on Liquid Galaxy. And now we observe the SO2 concentrations on Liquid Galaxy. So this is a proof that all the applications that are mentioned here are well integrated with the Liquid Galaxy setup, and the initial pre-requirements for task 3.1 are successfully completed by me. Thank you.
Hello, my name is Dhruv Sharma. I am an engineering student with my majors in information technology at Parul University. As you can see, I have successfully installed the Liquid Galaxy rigs on my system, and here you can see that we can easily roll it out. Now let's open the Bluestacks. Opening the Bluestacks and launching the Liquid Galaxy controller. As you can see, there are three options: Earth, Moon, and of course Mars. So let's go to Moon. As you can see, we are on the Moon now, and it is easily moving without any errors. Now again going back to the Earth. Let's say I have go to the location named Ahmedabad. I have searched it, and we are going to the Ahmedabad. So this is the installation and the prerequisite video for the Liquid Galaxy. Thank you.
Hello everyone, this is Karbir Joshi pursuing engineering from IIT BHU, and this is my proof of knowledge video for Liquid Galaxy task, where we were given basically to build a rig using virtual machines. The middle one is basically the master machine, and the either side ones are basically the slave machine. Here the task was to build the LG rig and make the three machines in perfect sync with each other. Here we can see that all the three machines are in perfect sync with each other. The second part of the task was to use the LG app to basically see the functioning of the LG rig. So here we have the Liquid Galaxy controller, and here we will be seeing the location of MIT. As seen in the screen, this is the location of MIT. Now we will be seeing the functioning through another app, that is La Palma Volcano Tracker. Here we will be seeing the prehistoric map of the volcano using Liquid Galaxy. So here in the screen you can see the prehistoric map of the volcano La Palma. Thank you so much. That's all for now.
Hi, my name is Kozir Williams, and I'm a postgraduate student at the Nnamdi Azikiwe University. I'm equally a Flutter developer at Savertech in Nigeria, and my drive has always been to be a part of the solution in the tech sector. Right now, I'll be showing you how much I've done on the preliminary test. Here are three rigs. The first rig, which is the master's rig, I crystaled it window 1. The second rig, window 2. The third rig, Windows 3. On the master's rig, which is Windows 1, you have the moon there. If I zoom into the moon, it spans from the masters all through to the slaves. So if I click on, that is it, the beauty of Liquid Galaxy. If I click on mass, and then I zoom on it moves, it spans through from the masters to the slaves. And then quickly I'll have to go to the Earth. Now on the Google Earth, I would want to show you somewhere I really love, and that is Otter Farm in Nigeria. Otter Farm is believed to be one of the biggest farm in Nigeria. And I believe in the future, Otter Farm will be able to use Liquid Galaxy to monitor crops for food security in Africa and the world at large. And if I zoom into it, you see Otter Farm poultry, livestock, and so on. Quickly, again, I want to take a tour around the world, and I'm going to be choosing the word airports. You'll be seeing beautiful places, uh, the views, how the view can move, not just in one screen. It could span from the master to the slave and so on. That's how beautiful it is. Subsequently, after this video, we'll be making another video for my Flutter and that code, where I will be displaying on the visual emulator 4 buttons for the second preliminary test. After that, I look forward to hearing from you. Thank you very much. Hello, my name is Kozi Williams, and I'm a postgraduate student at the Nnamdi Azikiwe University, Oka. I'm equally a Flutter developer with Savertech here in Nigeria. Today, I'm making a video to meet the pre-selection requirements on building my own Liquid Galaxy with 4 virtual machines. You could see at the top, I have 3 rigs and one of my app. I have 2 apps to display. I'm going to start with the Liquid Galaxy Controller app. And here you could see the planet Mars already. If I zoom into it, it comes up and then it spans through from the master's rig to the slaves. And this is the master's screen, and these are the slaves. All right, so I'm going to move over to the Earth, and I'm going to display the Earth from the master screen down to this other rigs. Here, I'm going to be showing you one place I love very much, and that is Otter Farm. The farm is believed to be the biggest farm in Nigeria, and I believe in the future, Otter Farm will be able to harness the usefulness of Liquid Galaxy to monitor crops for food security in Africa and the world at large. Now, if I zoom into it, you could see that if I zoom into it, you could see uh, the, the farm where it's located. All right, great. So I'm going to be taking a tour, and that tour I'm going to be taking is to show the world airports. And you could see how beautiful it is, how it spans from the master screen down to the slaves. And if I continue like this, it will keep moving, showing us other airports. So I'm going to stop this right now and then go over to the next app, which is the La Palma Volcano Tracker. And we're going to be looking at landscape map or historical track, and then on the map, going to view the map. So uh, here we go. You could see that how it spans through from the master to the slave. So with this, I've been able to show how I built my Liquid Galaxy with 4 virtual machines. I look forward to hearing from you. Thank you very much.
So hello, my name is Jayavardhan Shukla. I am from Vishweshwarya National Institute of Technology, Nagpur, which is in Maharashtra, India. So this video is a part of the preliminary submission to Liquid Galaxy. So basically, I have created these 3 virtual machines. This is LG1. The one on the left side of it is LG3. The one on the right side is LG2. So LG1 is the master machine, and as I move the master machine, the other 2 slave machines follow it as it is. So this is basically the first part. Now for the second part, I would just close one of these machines in order to avoid any memory lag or something like that. Now we'll open BlueStacks. LG controller. So I have followed along the documentation as it has provided and changed the IP address from the administration tools and then to settings. So now if I just click on the moon, uh, so here it is. This is the moon, and if we try to log in into the moon, this would go on to the same machines as well. And this is the surface of the moon. These are the craters in the moon surface. Yeah, sorry for the delay. So for the second application, we would move on to the La Palma volcano tracker. This is a So I have also configured this application, provided all the IP addresses and so on and so forth. So if I just click on the historic trap map, says ready to visualize. So now I would click on the map, and here it is, the historic map which is being loaded. So that is it for the second part of my video. Now I am waiting for a response. Thank you.
Hello, my name is Julio Cesar. I will talk about application. I developed a simple application that has the image of Liquid Galaxy, and for buttons, here you click on the button, it changes the background color of the application. This A class named My App has created the extension stage fluidity so that not a static page will create another class called My App Extension. That the extension state inside this class will create a variable that stores color and a function to charge the background color of the application, then will overwrite the build method placing the image and for buttons, and the click button calls the charger background function for charge the background color.
Hello, my name is Krishna Agarwal. I am a second year undergrad pursuing mathematics and computing at IIT Dhanbad, India. So this is the first app, Tiny UG Data Visualization Tool, and I'll just open one and send to LG. So you can see like this is working perfectly fine, and I'll just switch apps from home, and I'll open this app La Palma Volcano. This is the app, and we'll just check the connection. This is connected, and just go to info and like just start the orbit, and as you can see this is working with that. So this was the testing of two apps on the VirtualBox. Thank you.
Hello everyone, my name is Arsh Khan, a second year student from VJTI Mumbai. As per our second task, we have to make a Flutter app with Liquid Galaxy logo and 4 buttons in it, and code explanation as well. So let's start. So firstly, we'll start with the file structure that I have made. As you can see on my screen, there's an asset folder up here, which contains all the images that I use in our app. This is the logo, this is the Liquid Galaxy logo. Yes, so this is the lib folder where all the executable code of app will be stored here, and I have made a constant folder which contains the route.dart. It contains the route name,
which is used in main.dart, which will be used for routing from one page to another. This way is better because we don't have to change everywhere if I want to change it a route name. So this is a view folder. Currently I have two views in a app. This is a home view code. This is a stash view code. This is main.dart. Main.dart contains Flutter widget binding initialize. It is one of the important code important to make sure that you have an instance of widget binding which is required to use platform channels to call the native code. This is a run app. It contains material app inside. The home, the first view is the stash view, and it contains now route details. This is a home route. This is the only route in the app currently. And this is home view dot. This is a stateful widget. It can be a stateless widget, but there's nothing dynamic changes in this. But I made it as a stateful widget. This is an override. This is build context widget build, which builds the widget. I'm returning a scaffold with the background color with white. This is 255, 255, 255, 255. It's white color, as you can see here. And there's an app bar, which is called as the Liquid Galaxy demo app. Contains the title with some text styling with a font size to 20, font weight to bold, which being bold. I made center title equal to true, so it's in the center, and the background color is black. So this is a column, this is a body, so it contains a column. Column means widgets will be in column. It has a parameter called children. Firstly, I have made a size box of height equal to 5 because it was going inside, and I have used an animated container. There are two types of containers. One is a normal container, second is an animated container. It has a duration that I've set it to 0, it's to be static, and the decoration, the parameter decoration. And I have used a box decoration to make it a rectangle shape. I'm given a box radius 0.0, and I've used an image which is Liquid Galaxy's logos image with a height of 300 and width of 500. And I have also fitted. I also have a fit parameter boxfit.fit width. It will fit in a width. And then I have applied a size box to give a space between them, between the two widgets. And then I have applied a row for the thing. Like, I have four buttons 1 2 1 2 3 4 1 2 3 4. So the first two are in row with each other, and the second two are in the row with each other, and both are in column. So I must show you an example for that. As you can see here, this image, follow my cursor. This is two buttons are in row, and these two buttons are also in row with each other. So these two buttons are in row, these two buttons are also in row, and these buttons are in column with each other. Like these button 1, button 2 acts as a pair, and button 3, button 4 acts as a pair, and both are in column with each other. So going back to our code, we have a row, and we have a main axis alignment, which is like space evenly. So this buttons can space themselves evenly. Well, they are not cramping up. And I've used material. Then it takes a parameter shape which has rounded rectangular box, which is then it's a rectangular box. As you can see, it's a rectangular box, and it's a box border radius of 10, and there's a border side to be transparent. Now next is inkwell. Inkwell is when you want a rectangular area in rectangle or any shape area in Flutter that you want to respond to touch. I mean, when you touch the button, it needs to respond to something. So there's a command on tab when you touch. I have put to go to message on tab to message on tab, which will print, or it will show that which button was pressed. And to the sync well, there's a center parameter attached, and then a column. It has a parameter children. Then it contains a container, which this is a parameter decoration, box decoration, all with box IDs I have given, and it contains an image. This is a child. This image or asset, which is height width 110, width of 110, and it has fit parameter box fill. It fits the box, and this is the image that I have shown you in assets folder that I have stored, and I've given a text button. To summarize this, I'll show you. Here I have used here I have used a column. So this is an inkwell button, and then there's a text. There's a text, constant text button here. So these both are in column with each other, and these two buttons are in row with each other. And similarly for button 2, the same things, and similarly for all buttons is the same thing. Now let's talk about stash view. Stash view is a stateful widget. It contains a widget build function which requires a build context. It returns a scaffold, and inside a scaffold its body contains a container which has two parameters. This is the two important parameters. This is foreground decoration and decoration. Foreground decoration gets painted behind the children, and the foreground decoration gets painted like above, or you can say it after the children, in front of the children mostly. And what it means is the background, the decoration. It contains a decoration image, which contains an asset image, which is in assets. The background, black background, .jpeg. This is like when the stash view is open, and first the app will paint the background, the black color background, and then the foreground decoration is an asset which contains a Liquid Galaxy logo that gets paint above the black background. There's an alignment from border center for a button, the elevated button, which contains a padding also. It's from bottom. It insists not only bottom, from bottom. Then it has it is an elevated button. It is a parameter child, which has a child, and I have given the name to the button, giving a test to the button. Get started with some styling of him. Font weight, bold, font size, it's everything clear. And on pressing that elevated button, what should happen? I have part a navigator or push name from stash view to home view. If you press that button, it will go from stash view to home page route. I mean the home view. And this is the styling for the button, which has foreground color like the black color for the text, and background color is white. And this is the shape of the button. I can control that as well. And now I'll talk about how the code will run. First of all, the void main. It's the most important thing in main.dart. The main.dart files gets executed, and inside also void main is the important function that gets executed. So everything should be inside void main. So void main gets executed. So this is the first leave where it will go to stash view. It will open stash view, and Then from stash view, it will go to, if I press get started button from there, it will go to home view, and that's it. This is a very this is a very static pages. There's no things happening, like there's no dynamic things in it, uh, as it is a very simple app. And now I'll show you the demonstration. Let me start. Let me build this app. Now that our app is built, I'll start SCSCPY, so you can see my mobile screen as well. Yeah, this is my mobile screen up here. This is the stash view. As you can see, this is a stash view. It has a black background, and this is the Liquid Galaxy logo that we have talked about. And then this is a get started button. When I press this get started button, it takes me to the home view. Home view, it contains the Liquid Galaxy logo, and there are 4 buttons here. And when I press a button, as you can see a message. Button 1 was pressed. Now I press button 2. Button 2 was pressed. Button 3 was pressed. Button 4 was pressed. And this is the back button. Go back to the stash view as well. And now to summarize it all, I have made an APK for this app, which I will share in the drive link. And this is some I have pushed this code as well on GitHub, which I will provide the link in the email. And yeah, and thank you for patiently listening to me.
Hello everyone, my name is Mahinur. I'm a student in Cairo University and I'm currently studying computer engineering in my 3rd year. I'm really excited and looking forward to start my journey with Liquid Galaxy. And in order to start, I had to set up the Liquid Galaxy rig on my local machine. The rig consisted of 3 virtual machines all synced up together. This was built and used by the architecture of the master-slave architecture. Let's take a look together. So now, the LG1 in the middle is the master machine. If we just rotated the globe or just zoomed in, you can see that everything is just beautifully synced up together. Of course, we had also to install an Android emulator, and I used Bluestacks for this. This controls the whole rig. Now we are on the Earth, we can just move to the moon. Look, everything is just synced together. And the Bluestacks emulator just controls the whole rig. We can also just choose Mars. Yeah, so this is for the first app, and we can try also another app, which is the volcano tracker. But first, let's just get back to the Earth, yeah, okay. Now let's go to our volcano tracker app. We can choose anything from here, or we can just go to custom builder and maybe choose some of these. Okay, and we can visualize in LG. Yeah, so it shows us everything, yeah, and we can start orbiting too. Yeah, it just works. So this is it for now. Thank you.
Hello everyone, I'm Manas Darvi. I am a sophomore pursuing a degree in computer science from Vishwakarma Institute of Technology, Pune. And the first task given to me from Liquid Galaxy was to set up a virtual rig, Liquid Galaxy rig, and here I have completed the task successfully. So as you can see, here are the 3 virtual machines running Liquid Galaxy, and they are in sync. Now the second part of the task given to me was to control the rig via different applications given by Liquid Galaxy. So the first one being a Liquid Galaxy controller. So as you can see, if I choose the moon, here the moon is selected, and now the moon can also be viewed panoramically. And also the second application which I tried out was La Palma wall track. First I will go back to the earth. Now if I go to the prehistoric map, as you can see, I'm redirected to the Palmas Island. Now I can start the orbit. So this is also running successfully. Thank you.
Hello everyone, this is Manas Kumar from Indian Institute of Technology, Varanasi, and I'm in my second year pursuing electrical engineering. I'm here to present a video demonstration of the task 2 that was on Liquid Galaxy website. In the task 2, I have to create an app that with some buttons in it, and which when pressed should interact with the Liquid Galaxy virtual machine. So the Liquid Galaxy running on the virtual machine. So first we will look into the app and we'll see it live, functioning live, and then we will hop into its code. So here's the app, the LG app. As soon as we open the app, we are a splash screen is presented to us, and then after a few seconds we are redirected to the login screen, where we have to put in some credential to connect necessary to connect with the Liquid Galaxy rig. So we'll just write it down here, the port number to which the rig is listening and the number of rigs. And then we'll tap on connect. So we can see it has been connected, and that's why it is redirected to the this page with a button named IIT Varanasi at the center. Now when we click on this button, the rig will just rotate and get us to the location of IIT Varanasi. So you can see it is being rotated, and here we have the IIT campus with in a drone view. You can see with some tilt to have 3D effect or whatever. So this is the campus. So we can see the app is running smoothly, quite smoothly. Now we will hop into its code base. So here the code base of the app. So the app starts from the main.dart. As soon as the app is initiated, this initiate method is called, and it is redirected to the splash view. So here is our splash screen with this is the UI of the splash screen, which is a column with a video widget, the animation that has been played of Liquid Galaxy, and then the name of the liquid, and then we name the Liquid Galaxy. So this is the widget for playing the video. Here we have this video here, which we are accessing through video player controller dot asset and the name of and the address of the file from the root of the project. So this is the splash screen, and we have the splash screen model for it. It will just it is a future.delayed method which will perform some functions, or yes, it will perform some functions after some delay. So we have defined the delay in seconds, and which is 4 seconds. So after the 4 second, the splash screen is being played, and then after the 4 second, it will just pop the splash screen to reduce the load on widget stack to run our app more smoothly, and then it will redirect to login view. Now this is the login view where we have to put all the credentials which are defined already here. The controller for all the credentials that are being asked from user to fill. The username, IP address, password, port number, the number of rings, and so on. Now here I have defined a function called connect. It will be called when we tap this connect button here. When this function is called. So we are connecting to the LG through SSH client method, where we have to pass these 4 parameters called the IP address, the port number to which it is listening, the username of the machine, and the password of the machine, which we will just use the credential that the user has provided to these variables itself. And now we have the check status function. It will just check the status of the function from here. It is shown here, the connected. this function is checking whether it is connected or not. If it is connected, it will show connected and a tick mark, and if not, then it is disconnected and a cross mark. So this is the function for that, and then we have initialized everything here as soon as the widget is created. And here we have the UI of the widget with column row setup, with the heading being connection manager, then the status whether it is connected or disconnected, the icons for different things, and then the text form field for input that we will ask from the user. And then in the end we have the connect button here with on placed implemented connect. So as soon as we are connected successfully, okay, so as soon as we are connected successfully, you can see here we have so here we have okay, so the connect method was yes, yeah. Here is the connect method. So as soon as we are connected successfully, it will redirect us to home view, and if not, then it will redirect us to the error view. So now let's open to the home view. Let me just remove this import. Okay. So in the home view, we have some variables, and we have assigned some values. So there will be no problem of null check or the value being null when called, whatever like that. So here are few functions to play the orbit, stop the orbit, just to get to the place, and one button called IITBHORNC with on press function called lg.connection. In that class, we have this function called send to LG, the KML file we are sending to LG. We have here defined the we first get the credentials that the user has given to us. Then we will create a temporary file for the. So it is still showing some error. Let me just remove this as well. Okay, so here we were here. Yes. So here it is. So this will create a temporary local file for the KML that we are sending or uploading to LG through this function. We have just defined some initial values which will be overwritten from this KML file actually. Later on, when we send the file to the LG, and then that file in the LG will be executed through this to command. And now this function is to build the orbit. It is just to build the view that we are getting around that location. This is to just build the orbit that we are seeing in the map. This view actually, this view. Okay, so there are some few more functions to control the functionality of the view and LG itself. Now we have the KML files. I have this KML file here stored. This file is generated through Google Earth. Just get to the location and draw a polygon and then save it as a KML file. That file contains this content, and we have just only pasted that from the KML file to the app itself. This is the file that is being sent to the Liquid Galaxy, and we also have two files here. The orbit we were calling play orbit, stop orbit, and other functions. So they are being created from here. It's generating the orbit with some tags like to where to go, where to look at, and fly to, etc., etc. So we will just append these tags, this text with the tag here in the build orbit method that we have described already. Then we have look at which will contain the latitude, longitude, range, how much we can see, and the tilt to have some 3D effect, and the heading, the direction in which we are headed to, etc., etc. And this will send this to the map of the Google Earth. And other file we have here is the utils. Basically, the folder structure that I have used here is used for maintaining projects with much more files than that are in this project. So to make things smooth, actually, in the utils folder we usually define all the repetitive functions that are being used in the app. But here we only have one such function, the elevated button or the connect button. So and now moving on to the observe.yaml, the dependency that we have used here. The video player for playing the splash screen video, the set preference for saving the credential that the user has given us, and then we have the GIF dialog to it is used in error view, the alert box to make it more interesting or live with some GIF or animation. Then we have Google Fonts. Then we have get method to navigate through our widgets. Then we have HTTP request. Then we have SSH through which we will connect to LG. Then permission handle for different permission like network, location, etc., etc., and the path provider for saving the for accessing the path or defining the path for the temporary file that is being created while sending to the LG. So this is it for the code. from LG app, and we have already seen that the app is running smoothly. So that is that for the task 2 from my side. Thank you.
Hi, my name is Murilo. I am a computer engineer student at Facens, Sorocaba, Brazil. And today I'm gonna show you my virtual application of the Liquid Galaxy for the GSOC 2023. Here you can see the three virtual machines running, and here the Bluestacks running the Liquid Galaxy controller. As you can see here, the application is running as it should. Now we are going to see the Cristo Redentor. Here is the application, the first application, and now I'm gonna use as an example of the working environment the RAS2. Let me expand here. Launch. As you can see here, the two applications are running smoothly and without any problem. That's it. So I'm gonna explain to you why do I want each project. So first off, Liquid Art AI. Liquid Art AI is a project that why I want, because I love AI. Since I joined university, I have been part of Maya, a group of research of AI of the university. And art, I would like to show. I draw since I am 10, so art is too a great factor of my life. So I value this very much. So that's why it was my first choice. About what my competence about doing that. I work with art. That is one of the requirements. And Flutter with the Liquid Galaxy. And applying AI to that would be not a difficult task to me, because I already make many research and work on the field with the nuclear, with the center. So that's why I would like to work on that project in particularly, because the other is a second patient, I would say. I had a hobby of making games, and in Space Invaders is a game, and I thought that would be more easy to me to work on it, because I already had experience working on JavaScript games. Not was my focus, but I worked. So that's it. And that's each explanation. And thank you for the opportunity.
Hello there, my name is Nathan. I'm 19 years old. I'm currently coursing Mechatronics Engineering in Facens University, Sorocaba, Brazil. And I'm going to be showing my Liquid Galaxy setup today. It is a 3 machines setup, as you can see. The machines are behind the screens over there. And I'm also going to be showing 2 apps from previous GSOC events. The first one is going to be the La Palma Voltrack, developed by Yash. It gives you some info about some volcanic activity that has happened before. And There is also Setnox, developed by Michel. Oh, sorry. Wait a second. Here I'm not going to be showing any specific function. I want to see some Galaxy related. So I'm going to reboot the system. System reboot. So both of the applications are working. And yeah, that's pretty much it. Thanks for watching.
Hello everyone, I'm Paul Crescent, pursuing computer engineering third year in India. So now here I've set up like a Liquid Galaxy rig in my machine. So there are three virtual machines. The center one is the master machine, and the extreme ones are the slave machines. The slave machines are synchronized with the master machine. Whatever change is done in the master machine is reflected in the slave machine. As you can see, we have in the slave machine we have controllers to zoom in and to move to left and right. Okay. So these are so this is how it is. All the three machines are on the same network, and we have another thing is the emulator. So in that emulator, I've downloaded the Liquid Galaxy controller. So in that controller, using that controller, I could go to a specific location such as CN Tower. So here we could see the towers and other buildings, and we could also switch to other planets. We could switch to Moon. You can see the changes are done in the slave machines according to the master. We could also go to Mars. There's another feature in Liquid Galaxy is that we could enter into flight simulator. So now this is another feature. There are many applications that could be seen in using that could be done using Liquid Galaxy. So one such thing is a flight simulator. It's kind of hard to control too. Okay, now it's not very difficult. Okay. So this is the proof of video to apply for Liquid Galaxy. Thank you.
Hello, my name is Rafael Salgueiro. I'm a student of computer science at Universidad de Lleida in Spain, and this is my 4 virtual machines with the Liquid Galaxy. You can see it's fully working. And first of all, I want to try this application, the RAS. Charge the KML data. Perfect. And then I want to try this other application. That's the Satnos viewer. Well, here you have satellite charger and the simulation running. Perfect. Hello, my name is Rafael Salgueiro, and this is my 4 buttons app. This is the main activity. When you open the application, you will change this code. And I use a binding for taking all the components of the overlay, that is this one. And you have the 4 buttons. This button changes the color of all the buttons. These buttons open the Liquid Galaxy page in the application. This button increase this counter, and this button decrease this counter. Well, if you want to use the binding, you have to add this piece of code here, view binding true. Is it a good practice for the code? Well, with the binding you can check and take the 4 buttons element, and this is the 4 functions for the buttons. This function is for increase the counter by one position. This function is for decrease the button one function. This function is for open the Liquid Galaxy page, and this function opens this other overlay and search the web page here. This line of code is very important in order to open the web page in the application and not in the navigator. And this code up here is the button for change the colors randomly, as you can see. Well, and if you go in the overlays in the code, you can see that the text is in strings in this this is for changing the languages of the application and do it faster, and you don't have to write the code a lot of times. So this is the the application, the button that changes the colors, the button that increase the counter, the decreaser counter, and the Liquid Galaxy page open in the app, as you can see. It works perfect. And in the Android manifest, I added this line of code that this gives permission to the application to open the internet in the application and not in the navigator.
Hello everyone, this is Rick on this side. Currently, I am pursuing BTech from Computer Science Engineering with specialization in cybersecurity from India Institute of Technology. Today, I will be presenting the prelims for G-Shock 23 for Liquid Galaxy, and it is the prelims of setting of three rigs. I have used VM VirtualBox for the rig setup, and another set using Bluestacks, where I have loaded the Liquid Galaxy controller. Here, there are three setups. First, the master machine, that is LG1, which is running on VM VirtualBox, and two slave machines, that is LG2 and LG3, running simultaneously. Another part is the BlueStacks part, where where I have connected the BlueStacks using the network road, which I have already provided to the master machine of the VirtualBox, and rest two slaves, that is LG2 and LG3, is also connected by network marks in VM office already. So here we can see that the main machine, that is LG1, is in sync with other two machines, that is LG2 and LG3, and which is also running simultaneously as per the movement of the master machine. Here we have used the app called the Liquid Galaxy controller. So let's now open it. So the Liquid Galaxy controller app will now fetch the data from the virtual machines which I have already created and which you can view also. So here we can search any place. For example, I stay in Jatishwar, so I am searching Haldia in it. Haldia. We have to press the search button for the search purpose. Let's see. So yes, there it is. Now the app, that is La Palma Volcano, which is getting back to the app. Nice. And now let's track historic track map. The map is reaching towards it. That's good. So this is the prelim section for G-Shock 2023 for Liquid Galaxy. That's all. Thank you. Hello everyone, this is Rick on this side. Currently, I am pursuing BTech from Computer Science Engineering with specialization in cybersecurity from India Institute of Technology. Today, I will be presenting the prelims for G-Shock 23 for Liquid Galaxy, and it is the prelims of setting of three rigs. I have used VM VirtualBox for the rig setup, and another set using BlueStacks, where I have loaded the Liquid Galaxy controller. There are three setups. First, the master machine, that is LG1, which is running on VM VirtualBox, and two slave machines, that is LG2 and LG3, running simultaneously. Another part is the BlueStacks part, where where I have connected the BlueStacks using the network road, which I have already provided to the master machine of the VirtualBox, and rest two slaves, that is LG2 and LG3, is also connected by network marks in VM office already. So here we can see that the main machine, that is LG1, is in sync with other two machines, that is LG2 and LG3, and which is also running simultaneously as per the movement of the master machine. Here we have used the app called the Liquid Galaxy controller. So let's now open it. So the Liquid Galaxy controller app will now fetch the data from the virtual machines which I have already created and which you can view also. So here we can search any place. For example, I stay in Jatishwar, so I am searching Haldia in it. Haldia. We have to press the search button for the search purpose. Let's see. So yes, there it is. So this is the preliminary section for GSOC 2023 for Liquid Galaxy. That's all. Thank you.
Hello everyone, myself Tejas, and for the task 3.3 I was told to record a video because I was late about how I selected the project for making app from them. So first of all, I went to the website of GSOC 2022 of Liquid Galaxy, and similarly with 2021, and I saw the apps which were allotted to the students who were selected for year 2021 and 2022, and I check the projects on the Play Store link of Liquid Galaxy, if the apps were made and uploaded on Play Store or not, and after that, for those projects whose apps were not created and uploaded, I checked them on GitHub, and from there I selected three projects and I mailed it. It was due to my exams that I got late, but now I have selected the six projects out of three, of which I will making the proposal and sending it with this video. Thank you all. Hello everyone, I am Tejas Kumar again here, and today I am going to showcase the task 2, that was to create a Flutter app with 4 buttons and the logo of Liquid Galaxy. I created the simple app and I will showcase it here. Just a minute. So here is the code, and I am going to explain it, and to show the app I have it open on my mobile phone, and it is here. This is how it looks. I usually do prefer connecting my phone to the phone and then testing the app rather than doing it on emulator. And this is the app I use, Android Studio, and I imported the package. I will explain the code. I imported the package, and this is main, and here in main I'm returning this LG class, and this is a stateful widget. Here in LG we have a material app and then a scaffold, and in the body I have, here is the image, and image is coming from asset, and here I have put the image, and this is the button. I used elevated button here, and this is the code for the button, and then a sized box for giving gap between two buttons, and this is second button, this is third button in similar fashion, this is the last button. So this is a size box just for giving space in between. So this is the code. I have uploaded it on GitHub. Here on GitHub I have uploaded it, and I have even created a APK file. Here is the APK file, and I will upload them on Drive, and will email it with this video. And for a long time I was thinking of creating this app. I was thinking that I will, just a minute. What I was thinking was that I will use Google API and in the buttons, and just like La Palma app, which was showing the La Palma catastrophe, I will somehow show the Turkey-Syria earthquake, and where was the epicenter, and all these things I was thinking of showcasing in the application. But next week my college exams are coming, so I didn't have time, so I just created the simple app. I was told on Discord that on 22nd will be the last date. After that, thing will get little bit speedy, so I just created these app some the way it was given on the website, 4 buttons and one logo. After my exams are over, I will try that thing on Google API, just like La Palma, which was based on La Palma catastrophe. So this is my video, knowledge of a video, and this is the task 2. I named the application task 2, and you can see it again on the phone. And this is the app, and I even changed the icon. Yes, this is task 2, and this is how it opens. Liquid Galaxy 2. Okay, so here I will end my video. Thank you all.
Hello everyone, my name is Vedant Singh. I am a third year computer engineering student from Bharatiya Vidyapith University, Pune, India. This is an LG Liquid Galaxy virtual machine setup video. This is my proof of knowledge video. So stay with me, okay? So here are my 3 virtual machines. This is number 1, this is the master. This is the second virtual machine, this is the third virtual machine. Both of these are slave virtual machines. All of these are connected by NAT network. This is Google Earth working on it. The second part of the proof of knowledge is running applications, Liquid Galaxy applications. So I have taken 2 applications with me today, Liquid Galaxy Controller and La Palma World Track. Let's try the Liquid Galaxy Controller first. Okay, you know what, let's go to Mars directly. Let's go. Yes, this is cool. Okay. Okay, let's come back to Earth. Let's go to the Denver Art Museum around the world, and here we are. Beautiful. Sheesh. The thing about Liquid Galaxy projects are, the rigs are that they are very beautiful. Very beautiful. Okay. Yes. So this was one application. This was the Liquid Galaxy controller. Now we'll try the second application, La Palma Wall Track. Let's see. Okay. Let's see, what do we want to see here? Oh, oh, it's already showing the lava flow. Okay, and now it is closed. Okay, so let's see the tremor data, where in which places the tremor has occurred, and closed roads, which roads are closed. Visualize an LG. Let's see. Okay, so these are the locations where the tremor has occurred and the density. Now, well, there's a lot of tremor in this area because of the density. I can see that. And these are the closed roads. Well, bad for them, a lot of traffic. Yeah, yes. So this is how it works, and thank you. Looking forward to working with you, Liquid Galaxy. I really love how beautifully you've made this thing.